Last video we talked about variables and data. Variables were a way to represent data, but data on its own is not very useful unless you can actually interact with it and you can do things with data. You can do operations on data, such as addition, subtraction, multiplication, and division. Everyone knows these operations. You've been taught these operations since you were young, and you also know that all of these operations have symbols that represent the operation. And so when in math you are using the operations, you can represent addition with a plus or multiplication with the times symbol. C also has operations. And these four operations do exist in C. You can do this with all the data you have. C also has symbols, and the plus and minus symbols are the same, except for multiplication and division, we use slightly different symbols. We use the asterisk for multiplication, and we use the forward slash to denote division. So let's jump right in and take a look at how operations are used within programming. So I'm going to declare two variables. I'm going to declare a number 1, which is going to be 5, and a number 2, which is going to be 2. So what we want to do is we want to take these two variables and add them together. Naturally, we would write number 1 plus number 2. This statement here adds the two numbers together. But the main question is, where does this get stored? We need a variable to store the answer. So we would create a variable like sum. And now we have a variable called sum, which is equal to the sum of these two numbers. The computer will go and add these two numbers together and then store it in sum. So let's actually check if the computer is adding number 1 and number 2, or 5 and 2 in this case, and saving it within sum. To do this, we have to print out the variable sum so we can see what's actually going on. And I'll add a new line character so it looks better. And we don't have a return, so I'll put that in as well. So now that we have it set up, let's actually compile and run to see if it's working. Oh, and look at that, it does work. It adds 5 and 2 because that's what's in number 1 and 2, adds them together, stores them in sum. And then when we print out sum, it actually gives us the sum. So the same can be done for a difference and a product and a quotient. So let's try this out and see if all our operations are working. So as we can see, our sum is still correct, it hasn't changed. Our difference is correct as well. 5 minus 2 is in fact 3. And our product, 5 times 2, is in fact 10. Now our quotient seemed a little off. If you notice that it says 2, well, most of us would think that 5 divided by 2 is 2.5 or 2.5. But it's printing out 2. Now, why is it doing that? If we have 5 and 2, we would automatically assume that it's 2.5. But the computer doesn't actually look at this as the number 5 and 2. It looks at it as being the integer 5 and the integer 2. There's a difference in that. Instead of doing normal division on these integers, it does something called integer division, which is actually what you did when you were learning division for the first time. When you're learning division for the first time, you would look at this question and say that the answer is 2 remainder 1. And you can notice that our answer 2 is there. So that is what it's doing. It's calculating it as integer division. It says, well, what's 5 divided by 2? 2 remainder 1. And it just discards the 1 because you're only asking for what it actually divides to. So how would we fix this? How would we make it so it actually is printing out 2.5? If we know that it's being stored as an integer, so maybe we can change it and make it a double, our answer variable or our quotient variable as it is in our actual example, and try and see if we can fix it changing that variable into a double. So let's change our quotient into a double. Now remember, we have to update our format specifier to match a long float or the format specifier for double. And so when we actually run this again, let's see if we get the right answer this time. And look at that. It says 2.00000, which we're a little bit closer. We have decimals, but it still only says 2. It doesn't have the 2.5 that we're looking for. So why is that? Why does it not realize that it should be 2.5? It goes back to the way the computer actually looks at this problem. It looks at it as saying, well, we need to divide these two numbers. It looks at the right side only, and it doesn't actually care what's going on, where it's being stored. It just looks at the right side, and when it looks at the right side, it sees that there's two integers, and so it automatically realizes that it has to do integer division. And so when it's evaluating this, it does the integer division and realizes it's 2, and then says, okay, now that I have 2, I have to store that within answer. And so it says, well, answer is a double type and we have an integer number, so we have to convert it. And so when we convert 2 into a double, it becomes 2.0. So that's why it gives us that answer in our result. So how do we solve this? How do we make it so it actually is working? We have to tell the computer to not do integer division. We need to do normal division, real number division. To do that, all we have to do is change one of our variables into a double type, because once any of the variables are a floating point or a double type, it realizes that I can actually do full division. So if I just change number 1 into a double, saved and compiled, and then ran it, we would now see our answer of 2.5. It's correctly doing it. There's another way if we didn't want to actually change this into a int because we want it to remain it for, let's say, other lines of code. We can change these into a double right on the line. And you do something called casting, which sounds complex, but all it really means is that we put the type that we want it to be in brackets. So we want number 1 to be a double within the context of this line. So this temporarily changes number 1 into a double when it's being evaluated, which means when we output this again, or when we run it again, we'll get the actual 2.5 we're looking for. So remember, one or both of them in this case have to be a double. So if both of these were a double, it would still work, obviously. But it's just something you have to keep in mind, that if you know you need decimals and you need to calculate it using decimals, you have to make sure that those formats that you're using are double, either using casting or declaring them as double. So those are dealing with the basic operations, the basic 4 operations. Besides the basic operators I just shown you, C does have other operators, and there are 3 more I want to cover briefly in this video, and that is the modulus operator, the increment, and the decrement operators. The modulus operator actually has to do with what we were talking before, our problem of 5 divided by 2. And when we were talking about 5 divided by 2 and integer division, we said that the answer was 2 remainder 1. Now I said that when you write 5 divided by 2, you get the 2. But what if you actually wanted the remainder of the division? Let's say I wanted to figure out what the remainder of 5 divided by 2, and I wanted to know that that was 1. That's where the modulus operator comes in. The modulus operator uses the percentage sign as the symbol. So if I write 5 percentage sign 2, it will give me the answer 1, because that is the mod of 5 and 2. So if I update our program to have a remainder like so, and I would write that the remainder is number 1 mod number 2. So if I print out our remainder, and when I run this program, you can see that our remainder is 1. Now remember that this only applies during integer division, so you can only use the modulus operator when you're working with integers. It will not work if you have double types used with the modulus operator. You have to use two integers. The increment and decrement operator is actually more of a shortcut operator. It basically lets you increase the value of a variable by 1 or decrease a variable value by 1. So if I have x is equal to 5, and I've declared this already, I can increase the value of x normally by saying x is equal to x plus 1, which basically says take the value of x, add 1 to it, so now it's 6, and make it x. But what if I just wanted to say this really quickly? I can just simply write x plus plus, which will increase the value of x. So if this was actual code right now, at the end of all three lines, x would be set to 7. The decrement operator works the exact same way. So if I have y is equal to 5, you can decrease it normally by saying y is equal to y minus 1. So you can shorten this by just saying y minus minus. So I'll show you a quick example so it makes a bit more sense. Here I have some code, and all it does right now is it sets x to -2. So if I run this, and then it prints it all out. Nothing actually changes the variable. So what I am going to do is I'm going to say x plus plus, x plus plus, x plus plus, x minus minus, x minus minus, x minus minus. So now when I run this, you can see that it increases x to -1, then 0, then up to 1. Then it starts going back down once it starts using the decrement operator to go all the way back to -2. So that's all the increment and decrement operators do. They're just a shortcut, and it can be useful when you want to simply increase the value of a variable or decrease a variable by 1.